Well, good afternoon, students. Today we're going to be learning about squares, cubes, and their roots. Our I can statements today are I can evaluate perfect square and cube roots, and I can recognize taking a perfect square root or cube root is the inverse of squaring and cubing. In other words, really it's just telling you that you understand and recognize that those are opposite operations of one another. So obviously our vocabulary today is going to be square, square root, cube, and cube root. You will hear me talk about and discuss this vocabulary in further detail today. How many square units are in this figure? So to start with, we have to remember the formula for area of a square. The formula for area of a square is going to be A is equal to S squared or side squared. So we're just going to count across, and I see that there are 1, 2, 3, 4 units. So I'm just going to call that 4 units. And then if it's a square, the same thing should be true for the height as well. So we're going to say 1, 2, 3, 4. So yes, that is going to look like 4 units as well. So I know you can count and you can see how many total square units are in this figure, but it's easier just to plug in and say 4 times 4, or 4 squared, is equal to 16 units squared, or square units. So we just multiplied the number by itself to get our answer. So if that is true, then the opposite is true as well. It says how many units across is this figure? So if 4 times 4 is 16, then if we know the units, there are 16 square units in this figure. So if I find the square root of 16, then I can identify the units across the figure. So the square root of 16 is equal to 4 units. So opposite of one another, 4 times 4 is 16, or the square root of 16 is going to give me 4 units. Let's take another example like that. It says how many square units are in this figure? So yeah, obviously I could go and I could count each square unit that I see, but instead of doing that, let's just use and remember the formula of square. So area is equal to side squared. So we're going to count 1, 2, 3, 4, 5, 6. So if it's 6 units across, then it also should be 6 units high. 1, 2, 3, 4, 5, 6. So we were right about that. So that's also 6 units. So if I plug into my formula side squared, then it's 6 squared, or 6 times 6, which is equal to 36 units squared. So the opposite should be true as well. How many units across is this figure? Well, if we know that it's 36 units, total square units, then the square root of 36 is going to give me 1 side length. So that would be 6 units. So those are visuals to discuss what we're doing, and that way you can see 6 times 6 is 36, and the square root of 36 is 6 units. But let's just take some problems that don't have a visual to go along with it. So our first problem says evaluate the square root of the following. So we want to know the square root of 121. In other words, what number do we multiply by itself to get 121? Well, I know that 11 times 11 is 121, but also negative 11 times negative 11 is 121, because we know that a negative times a negative gives us a positive. So as far as our answer is concerned for number 1, you're going to say 11 and negative 11, or the shorthand of that is you can just use a plus or minus sign in front of an 11. So plus minus 11, final answer. Either one of those answers is acceptable. You can write it as the 11 and negative 11, or you can write it as positive negative 11. Number 2 says the negative square root of 49. So we treat a square root bar just like we would any sort of order of operations symbol. So if I was going to do something in parentheses, then I would always, my eyes would go to that. That's what I would do first. Well, it's the same thing here. So in other words, we're just going to kind of remember that that negative is out in front, but we're not going to do anything with it right now. We're going to say, what is the square root of 49? Well, the square root of 49 is 7. And then all you have to do is bring the negative down. So our final answer then would be -7. As far as if it was written like this, I hope some of you are thinking, that's interesting. I can't get a negative because I can't multiply 7 times 7 and get a -49. And I can't multiply -7 times -7 to get a +40 or to get a -49. Therefore, that type of problem is not possible, not for what you guys know right now. It is, however, okay to have the negative outside of the square root bar. Moving on. Now we're going to evaluate, we're going to do some squares. You'll notice that 1, 2, and 3 look very much alike. You're evaluating some sort of 12 and you're squaring it. Well, let's see what that looks like. I want you to write yourself a note right now that says the exponent only applies to the base. And I'll tell you what we mean as we go throughout that. Number 1 says 12 squared. Well, I know that 12 squared means 12 times 12, and that is going to be 144. Would I want you to show your work? Yeah, absolutely. Show me, what does 12 squared mean? Well, 12 squared means 12 times 12, which is 144. As far as number 2 is concerned, if I'm telling you that the exponent only applies to the base, then what I mean is that there are 3 parts to this, really 2 parts, negative and then 12 raised to the second power. So if the exponent only applies to the base, then it applies to just the number 12. So what that means then is 12 times 12, which is 144, and then you bring the negative to follow. So the exponent and the base number of 12 in this case have to stay together, but the negative really is just kind of out there in front. Let's see how that compares to number 3. Notice that number 2, look at number 2 and look at number 3, kind of sidestep those. Number 2, you don't see parentheses. Number 3, you do see parentheses. So when I tell you that the exponent only applies to the base, it's going to depend on how the problem looks. So like in number 12, or I'm sorry, number 2, we were just squaring the 12. On number 3, because -12 is in parentheses, then we have to square the entire thing. So number 3 means -12 times -12. Which is, of course, a positive 144. So you can see that number 1, 2, and 3, although they had some similarities with the different parentheses or with a negative, then your answer certainly can change. So you just have to know how to approach each of those problems.